Alright, so this is a couple problems from the homework accuracy. I had a request to give a more in-depth explanation as to what was going on here. So in number one, it states if the measures of the acute angles of a right triangle are 2x plus 4 and 3x minus 9, we need to find x. Well, hopefully right now you're thinking, well, if they're talking about a triangle, maybe I should draw one. Well, I already did. So here we have a right triangle. Now, in the right triangle, it states, obviously, well, it's a right triangle. I'm going to have one angle that is 90 degrees. It also states that the measures of the other angles are 2x plus 4. So after we draw our diagram, we're going to go ahead and mark it up, fill in the information. So one of the angles is 2x plus 4. The other angle was 3x minus 9. Okay, and now we look at the triangle and we say, oh, well, I know that the three angles of a triangle have to sum to 180 degrees. So the sum of these three angles must be that. So I'm going to start with the one I know here, 90 degrees, plus 2x plus 4 plus 3x minus 9. Okay. Now we just need to do a little algebra. I'm going to combine these like terms here. So I get 5x, okay, 2x plus 3x. The 180s staying the same. And then I'm going to add up all of the constants or numbers. 90 plus 4 minus 9 is 85. Subtract 85 from both sides. We get 95 is equal to 5x. Divide both sides by 5. And we're left with x is equal to, see if I can do that in my head, it should be 19. All right, moving right along to number 2. So number 2, it says the lengths of the sides of a right triangle are 2x plus 5, 3x plus 10, and x plus 12. Find all values of x. Now you notice all is in red. That should be a little bit of a hint. Of x that make the triangle isosceles. Okay? So our goal now is to find all the sides of the triangle that would make, or all of the x values that would make our triangle isosceles. Well, we have a few options. Well, an isosceles triangle, I know, has two congruent sides. Now, I drew this, and obviously on my sides here, they are not actually congruent, but that's okay. I put some marks here, and they're now congruent. So what I'm going to do is I'm going to say, well, I don't know which sides these can be, so let's pick some. So I'm going to go ahead and start with 2x plus 5 here. Do that one. And 3x plus 10. Maybe those are my isosceles sides. Well, if they're isosceles, then they have to be, you guessed it, if they're congruent, they have to be equal. So I can set these two equal to each other. And that's the relationship we were looking for. 2x plus 5 is equal to 3x plus 10. Now we solve. I'm going to subtract 2x from both sides to avoid any negatives. Okay. I get 5 is equal to x plus 10. Subtract 10 from both sides. Oh, and in my quest to avoid negatives, what did I get? I got x is equal to negative 5. Now, it's not necessarily that bad that x is negative 5, but if I plug that in, well, what type of side do I end up with? I get negative 10 plus 5. I end up with a negative side. Well, that's no good. I can't have a negative side. So I know that even though this works for making these two equal, that is not a possible value. Okay? So I'm going to go ahead, and I know that I already used these two sides in that combination. I'm going to change one of my sides now. Not both, but just one. So I already used 2x plus 5 and 3x plus 10. I'm going to go ahead and just change one. Doesn't matter which one you change. We're going to change the other one in a second, x plus 12. So I keep stock that I already set those two equal. I'm going to set two different sides equal and see if that works. 2x plus 5 is equal to x plus 12. Now I subtract x from both sides. Again, in my quest to avoid some negatives, I get x plus 5 is equal to 12. Almost off the page. Okay. Then I get, I subtract 5 from both sides, and I get x is equal to 7. Well, that's looking a lot better. I don't have a negative here. I'm not subtracting ever. I know that this is going to work. Well, I have one more combination to try. I tried 2x plus 5 and x plus 12. I tried 2x plus 5 and 3x plus 10. Now I need to try 3x plus 10 and x plus 12. So I'm going to change this one here to 3x plus 10. Okay, and we're going to test it out. 3x plus 10 is equal to x plus 12. Subtract x from both sides. We get 2x plus 10 is equal to 12. Subtract 10 from both sides. Now we get 2x is equal to 2. Divide both sides by 2, and now x is all by itself, and it is equal to 1. Now a quick check tells me, well, this is a positive number, and I'm doing nothing but adding up there. So these two are my solutions, and if you want to get fancy, you can say that x is equal to the set of 1 and 7.